In the next couple examples, I want to show you how to simplify some logarithmic expressions. Now the game is to try to take the inside of your logarithmic expression and express it using the same base as your logarithm. So in this case, we're going to try to transfer 36 into an exponential expression where 6 is the base. We know that 36 is 6 squared. Now that the base of our exponential expression as well as the base of our logarithm are equal, these operations are going to undo each other, and we're going to be left with just the power of our exponential expression, which is 2. Some simplifications can get a little bit tricky, but the idea is to try to relate this inside number to the base. So in this particular case, is there a relationship between the numbers 2 and 8? Well, if you know your cube numbers, you know that 2 cubed is equal to 8, or the cube root of 8 is equal to 2. And if we rewrite this using a fractional power, we have 8 to the 1/3 is equal to 2. So this means we can come back over here. We can write this as log 8. We're going to change our 2 into 8 to the 1/3. So now our logarithm as well as our exponential expression have the same base. So those two operations are going to undo each other, and we're going to be left with just the power of the exponential expression, which is 1/3. Next, let's take a look at how to transfer a logarithmic expression into exponential form. Here we have log with base 3 of 2x is equal to 40. Now recall the definition of our logarithm. That is, if we have an expression log base a of b is equal to x, this is the same thing as the exponential function with base a is equal to b. Or that is, this value inside of our logarithmic expression, in order for this equation to be true, must be a to the power of x. So how does this work for our current logarithmic equation? Well, I tend to start with what's inside of my logarithmic expression. I'm going to write 2x as the right-hand side of our exponential form. What does 2x have to be equivalent to? Well, in order for this overall equation to make sense, 2x has to be equivalent to 3 to the power of 40. Why is this true? Well, we know that log with a base of 3 of 3 to the power of 40 is going to simplify to give us 40. So that tells us here that this 2x must be 3 to the power of 40 in order for this equation to be truthful. Now, let's say we have an equation in exponential form and we'd like to express it in logarithmic form. Well, according to the definition of the logarithm, log with base a of b is the solution to a to the x is equal to b. So here we have 2 to the 2t is equal to 10. So here it must be that the log of base 2 of 10 is the solution to our exponential equation, or all of this is equivalent to 2t.